All right, so here we go. I am aware these are tricky. This is the first one we've tried. We will practice more of them, mostly tomorrow, because we have a lab today. But let's look. We learned it double replacement reactions, and most people that tried it did this right. You just cut the front side off. So I'm going to put Cu and something, and I'm going to put H and something. And then they switch partners, correct? So H comes over here, Cu goes over here. So Cu's new friend is this, C2H3O2. Now, I'm going to leave that as written for a second. And then H is now hanging out with who? OH minus, makes water. Now, my friends, this is super important. Can anyone tell me why this 2 is even here? Nope. Thank you for guessing. That's because that's the charge of copper. Remember the drop and swap? All right. So tell me something. Look at the screen. Should I have OH2 right here then? No, because is hydroxide with copper anymore? No. Okay, so where does this 2 really go? All right, it goes here. All right, so look at the screen for a second. In these relationships, remember the subscripts come from the other person. So the 2 does not belong to OH. The 2 belonged to copper's partner. Copper's partner. Okay? They broke up. They've moved on. But the charges, they go with their other partner now. Okay, now we know water is just HOH, so I'm not going to worry too much about balancing the plus and minuses. So the last step would be to just put the coefficients now. Will you try that? Okay, this one's not usually awful. How you doing, Curtis? Your knee feeling all right?
I fell trying to get up here.
Oh man,
But other than that, I'm pretty good.
I'm sorry. Do you have an elevator key?
I do.
Okay. All right. So to balance it, I can fix the 2 there or the 2 here. Okay, sorry. I will pause.
Never mind, just do it. I give up.
All right. What? You give up?
Yeah, I was balancing without looking at the CUOH too. So
That's rough. All right, there's 2 OHs, 2 acetates, so I can start either way. If I have 2 H's, I know I for sure need a 2 here. That makes 2 H's, so I must need a 2 here. That makes 2 acetates, and I have 2 acetates, so it's done. So 1, 2, 1, 1. All right. Tricky, I'm aware of that, but doable. We'll practice these. All right, turn to page 7, and we're going to work on a lab today that's super fun.
Odessa has a question.
Odessa, yes. No, that's a great question because you put HOH first. All right, no, it does not matter. That was really good. Yeah, the order doesn't matter, just the way you put them together matters. All right. The bottle lab is on page 7. It's called Bottle Bewilderment. I absolutely love this lab because it's hard. You're like, what? The lab part is a piece of cake, but learning and applying, those are the tricky pieces. Let's see, that's not going to all fit, but it's closer. All right, this piece of paper that I'm reading right now is also in the yellow folder that's right over here on the lab bench. Okay, So this is one lab where you have to have the instruction sheet because you can't figure the lab out without it. Okay, here we go. Imagine you are a chemistry teacher. Oh, what a dream that is. You guys, this life is amazing. I can't think of any reasons why, but trust me, it's pretty awesome. All right. You're supposed to laugh right there, or you just feel stupid. All right. Okay, wear your safety goggles for the entire experiment. I will put these over here. You have to have safety glasses on. Oh, that was probably loud. Sorry, Tanner. All right. You will need safety glasses. Next, it says consult your instructor on how to properly dispose of these chemicals. This is extremely important. We've done this a couple times. You eat it. That is correct. No, it's not. You are going to fill this tray with stuff. Some of it's going to be toxic. So you can't just put it in the sink. So after you've done all the reactions and you have all the colors in here, you take your tray, take it to the garbage, and tap everything out. This is the only time you also need to wipe it clean first over the garbage, throw the paper towel in there. And then, I know it's a pain, but then you got to wash it, okay? There are 3 hazardous chemicals in the lab today that we cannot put down the sink. What? These? These are the pipette holders we've used. Yeah, it probably does. Usually I have them set up, but I had a department head meeting today. So that's part of the lab too. When you come over here, grab one of these. We just need really one per big lab station. So just one of you come over here, put A, B, C, D, E, and F in it. Okay, we got to use these because if you don't and you put A, B, C, D, E, and F on the table, then you get little drops of the chemicals. And then people put their arm down and they get little burns right here. So please use that. Okay. All right, here we go. We are chemistry teachers. You just made up 6 solutions, placing them in bottles labeled A through F. Those are right here by these ladies. There's bottles A through F right there, correct? All right, good answer. Okay, you made the following solutions. All right, this is important. These things are the reactants. Tell your partner which side of the arrow reactants go on. I didn't hear any words. I see one person pointing. Well, does no one know? It's the left side. So today you're going to write out reactions. These always go on the left. These are the 6 solutions that are in bottles labeled A through F. Now, all of these solutions are colorless. That's kind of false. A is turned a little bit yellow already, but no big deal. All right, yikes, you forgot to do one thing. You did not write down which solution was placed in each bottle. Oh, man, you're screwed. All right. Panic-stricken, you desperately try to remember what you did, but to no avail. You guys stop talking, please. You do, however, remember that Ki is in the bottle labeled A. So right now, right here, I would put Ki. All right, this is on page 7. So that is the one we know. Potassium iodide is in bottle number 1. We can use chemistry to figure out the rest of them. It's kind of cool, actually. All right. Nope. You will see that right here. Tasting is out of the question. All right, yikes, you forgot I already said that. Then suddenly you realize you are a pretty tricky chemistry teacher. Since your class had just finished a unit on equation writing, you shift the burden to them. Knowing all of these are colorless and that tasting is out of the question, you will probably need to investigate how these solutions might react with each other. Okay, We're going to investigate how the solutions react, and then we'll use our brains. Because you are rather intelligent, you know that each chemical will produce a colored precipitate like yesterday. Well, the instructions tell you it does, so there you go. Remember the yellow stuff I made yesterday? It's right there now. Can you see it? It precipitated, or it fell to the bottom now. So this, you will make one of these yellow precipitates in your little micro well, and that is yellow. So you'll know, hey, well, that thing right there that's yellow is PBI. It's more dense and solid. All right, now these right here are my products. Not gold, the color gold. The products, where do they always go on the arrow? On the right. That was much better. Okay. So look at this. It's this logic path we need to use real quick. We know that yesterday I made that yellow precipitate, right? Okay, so I'm going to say I had bottle X plus Y, and it made yellow. Just kind of think about this idea. So what we would know is that yellow is PbI2. So I'm going to put this PbI2. Sort of with me so far? All right, now look. What's the only bottle we did know? All right, we knew that A, so maybe I should have just put an A right here. We knew A was Ki. So A, or Ki plus something, made PbI, oh, that's terrible, 2. Now, so what? All right, the K's over there, there's more here, plus K something. But my other question is, where did the PB come from? It has to have come from here. So look with me. We know PbI2 is at the party. We know that the I came with K. PB must be here. And we got to see who it came with. And to do that, we look at the top of the page. That would mean that bottle Y would be PbC2H3O2, because that's the only way, oh boy, that's the only way it could have got there. So left over, we have KC2H3O2. Okay, I know it's weird and a little bit of tricky thought there. That is one of them, but there's not a bottle Y, so you'll have to figure that out for yourself. But first, we're going to get honor roll stuff. So let me grab those real fast. Hopefully they're all absent so I can eat them. All right. David Sid Sue. My fault. Which one of these would you like? All right. Odessa coming at you. What would you like? Amber Brown.
There's no more Kit Kat.
There's got to be way more than this, I'm sure. You'll get them later. Kennedy, I'm going to go around Savannah and land it right where you sit. Oh, this is pretty close. No, you can share it with someone else. There you go. All right. Okay, back to the lab. If we can figure out who's there and we know one of the things that brought them there, we can figure out the other. Okay. Now, look right here. Once you identify what the bottles are, you label them right here. So let's pretend this said bottle Y. We just figured out, well, that's PbC2H3O22. Now, there isn't one there, But that when you figure out what a bottle is, put its identity here, and then you can figure out the next one and the next one. Okay, final thing. Down here it says give the balanced chemical equation for each of the following color-producing reactions. So lead 2 iodide. What you need to do here is you come back and you find lead 2 iodide on the instructions is PbI2. It's the one we already did. So we would say we have our arrow, and this thing is always the product. So I'm going to put PbI2. And then we know it has to come from Ki and PbC2H3O2. Now, yeah, go ahead.
We can write this part, but we still don't know what bottle.
Right. Okay, now, matter doesn't just disappear, so we do have to include the other parts. KC2H3O2.
Wait, what are we missing though?
You don't know which bottle is PbI or PB yet. Okay. Ouch. That didn't feel very good. Okay, how many of you don't have to like admit anything deep here, but you went to True B last year? Okay. Okay, so based on his response, I'm assuming you kissed people. Don't name them, but you probably did. All right. Then there's other people that go to True B and don't kiss anyone, right? What's that? They're there to watch. Okay, now I know that's awkward, but look right here. These 4 people showed up to the party, but these are the only 2 people that actually did anything. And then these guys were just there. There's actually a science word for these. This is the precipitate, and these are the spectator ions. They're just there to watch. They didn't really do anything. They were there, but really this PbI2 is what was involved. Okay, now I heard Kennedy, and I love when this happens. When I give directions, I have them up there, and then kids say, I have no idea what I'm doing. All right, well, figure it out. There's written instructions. Okay, when you, on this part right here, oh, you said I have an idea. Okay, sorry, I thought you said I have no idea. My fault. Okay, sorry, Kennedy. My fault. Okay, up here. I heard Savannah say, I have no idea. This little table right here represents a micro well plate. So you just mix A and B, and all you have to write is the color produced. That's all you're looking for here. Then once you know the colors and you have the direction sheet, you can reason this through. Okay. I think that we can do it. Wash your hands when you're done. I have to tell you one thing. Jared, since you're up, hit the lights for me. Touch them. Much better. Do you see these pipettes? All right. Letter B, that liquid turns plastic black. If you get B on your skin, you'll get black spots or black marks on your skin for the next 2 days. Don't call 911 tonight. All you did, remember the iron in that? This stuff, it just comes out and it sticks to your skin and turns it black. You need to wash your hands when you're done, but don't panic tonight if you have black marks here or a little on your finger. You're just fine. It will burn if you leave it on. That's why you should definitely wash your hands when you're done. And don't purposely do it. I had a kid do that once, put it on Twitter, put a whole line down his arm, and then he got a U and never did a lab again. So if you're going to screw around, don't put it on social media. There's people that learned that a few days ago. Okay, when you come back here, once again, send one person to fill up your block, A, B, C, D, E, F. When you go to the back, fill it up. You don't need to empty these ever. You can just leave them for next hour. So when you have your block done and you take it to your station, just leave it there the rest of the day. Fair enough? Okay, have fun. Safety glasses are here. Instructions are there. Tanner, I'll put you in a group on an iPad real fast.
Okay.
Jared, I'm going to have you grab that iPad and work with Tanner. It should be unlocked. Yes. Oh, there's two people. All right, Ashton, I didn't know you're on there. Welcome. I'm gonna make a breakout room and put all three of you guys in it. And then Jared, what's that? You can go with whoever you want. Then Jared will run the show. All right, you'll have to accept that and join with him.
Am I supposed to press join?
Yes, hit join. Then there's a couple on there actually. Then we're gonna start video, join audio.
Hi, Tanner.
I don't know if he's here yet.
Well, what are you doing?
Okay, they're in.
Hi, Tanner. I'm gonna leave you here so I can go fill these up. Never mind. You're coming with me. Oh, why am I over here? Sorry, Tanner. I'm a little lost. I want to be able to see myself.
Oh, I thought I made it big.